and I will be the moderator for this session. Before we begin, I'd like to ask everyone to please turn off their microphones and their cameras during the presentation. If you do have any questions, please type it in the chat and I will ask it to Dave. And before we begin, I'd like to introduce Dave, our speaker for today. David McComas is a NASA emeritus, and after serving the NASA Goddard Space Flight Center for 34 years, sorry, my computer froze a little bit. His career includes developing and testing flight simulator software, maintaining in-orbit software, and leading software development teams. David primarily worked in-house flight projects, starting as a flight software developer for the Hubble Space Telescope, and concluding the flight software project lead for the Global Precipitation Measurement, which launched in 2014. Prior to his retirement, David served as the program manager for NASA's open source core flight system. Now I'll turn it over to you, Dave.
Okay, can you hear me?
Yes.
Okay, great. I wasn't sure if I muted and I didn't see the bar anymore. So yes, thanks, Aaron, for the introduction. And thanks everybody for attending today. I'd also like to thank all the people at Goddard for who were behind the scenes putting on these webinars. I always know that's a lot of work when you do things like that. So as Aaron said, my name's Dave McComas, and I'm an emeritus. After 34 years of retiring, this is a project that I actually started kind of on the side on my own while I was at Goddard, and it's kind of evolved, and this is actually a very good opportunity for me to kind of focus and figure out where I do want to take it now that I have more time. So, oops, that's it. There it goes. Okay. So I got a pretty simple agenda, and it actually follows kind of where my thoughts are on the OpenSatKit itself. First, I'll do a cFS and OpenSatKit high-level overview, and then I'm going to go through using the OpenSatKit as an educational platform for the cFS and apps. And a more recent idea has been more as an app development kit, and with a goal of kind of maybe getting towards this app store that we've all talked about for years. And then finally, I'll have kit extensions, and then with a wrap-up slide. And my cFS overview is brief. So if you didn't attend Alan Cudmore's cFS webinar yesterday, I recommend that you go back and look at that video. He gave a real nice cFS overview. And also, I'd like to mention that after this webinar, Matt Grubb will be hosting a webinar on the NASA Operational Simulator for Small Satellites, or NOS Cubed. And NOS Cubed and OpenSatKit both use Cosmos and 42 Simulator and cFS, but they're actually very complementary because I've started more on the educational side, and NOS Cube's more of a practitioner working on the mission lifecycle. And we'll get into that in a little bit. So first, for a brief overview, as not knowing the background of everybody in the audience, cFS uses a three-tiered software architecture that provides a portable framework, but also more like a product line deployment model. So what I mean by that is we start from the bottom up. We have the platform abstraction layer, and that has the OS abstraction and the PS, platform support package abstraction. And these have a well-defined API that then hosts the service layer, which is the core flight executive. And that also has a well-defined API. And the core flight executive provides 5 services in a runtime environment for applications. So then the applications in turn can be ported across platforms. And the reason I say product line deployment model is because there's a lot of compile time configuration parameters, and as well as runtime parameters that can be set from commands or tables. So that's what gives it, the scalability and the other abilities like adaptability and things like that. So I guess we'll go on to the product model. And you might think it's a little odd that I titled the slide product model because it is a government organization. And so it's going to have, so the government's not structured like a private company in terms of supporting products. So there's going to be challenges. And when I mention these challenges, I don't mean them to be critical because I'm actually part of the team that got us to where we are today. So any of the things where I see a need for the community, and a lot of these are actually as a result of, it's a NASA governance in a constrained environment. And luckily, recently, one of the nice things in the past year, which has been a big improvement, is we've been able to switch to an Apache license and also get user contribution license agreements on a much faster pace. So now we're on GitHub, the framework is, and I'll get into that in a second. And that way we can leverage the community, can be more engaged as well. So looking at this diagram, in the bottom left is the NASA board, and the way the cFS framework, which I forgot to mention the last slide, those first two layers are the framework. And that framework is managed by a NASA multi-center configuration control board. And that board really is made up of people that are funded locally. So it's not like there's a central budget. So a lot of the new features of the cFS framework are going to be funded. They're going to be community contributions, and also as a project needs something, we can advance it. And the model I always thought about when I was there was, we could have component specifications, and component by that, I'm really thinking of platforms and applications. And then there'd be suppliers, and NASA's a supplier, anybody could be a supplier. And then the framework would come out, and then a distributor would combine these into a cFS distribution. And that's really what OpenSatKit is. And I guess one other terminology is cFS itself. That term, the layers that I mentioned, they were released in evolutionary. So we first called the first two layers Core Flight Executive, and then really it's the middle, but it was kind of the both. And then we added the apps and released them, and then we had to call something, so we called it Core Flight System. But there is really no one Core Flight System, since you can combine any apps you want and create a distribution. So some of the challenges that we see over the last few years are, one is adoption. And this is hard because, as I said, it's evolved, and a lot of the documentation is, it's just for individual components. So there's a lot of components out there, and people are, it's hard to figure out, how do I use this as a system? And I also dashed the component specification because it's, they're not really formal specifications. And, one of the goals I'm going to mention is, if we want to have tool-based automated integration of an app into a system, it's going to have to get more formalized and saying, this is how you package an app. Kind of, I could say it's similar to maybe an Android app or something that a person can develop and package and have it integrated into the phone. And as a result of that, we've seen some, it's not a rapid growth of community and assets. There's definitely been a lot of good things out there, but it's, I think we could have a lot more. And there's other things that some people might not be aware of. Some of our apps that we released have things like table generation tools, and they've had limited, as far as I'm aware, they're not any generalized tools, because you'd need an infrastructure in order to have the command and telemetry definitions standardized in a way that a tool could depend on. Then we also have systems engineering challenges of locating and assembling. And I put inadequate, that might be a little strong. We have a mailing list, which is great, but it's not like, again, we're not a private company with a help desk line. So now that's the cFS overview. Hopefully that was enough to set the context. Next is the OpenSatKit overview. So as I mentioned, the real goals are cFS training and application development and integration. I'm using the Cosmos command and control. It's an open source tool. And then it's on, right now I've been, targeting Ubuntu, because I'm the one working on it. And that's another future goal I might want to think about. But it's, it's a challenge even sometimes across Ubuntu upgrades, things break and it takes time to keep everything working. So, and then yes.
Is there a link to the mailing list sign up?
Yes, there is. I have a resource slide at the end, and I'll try to freeze that when we have other questions, so that way people can have it in the presentation. Yep.
Thank you.
Sure. Then, so we have the dynamic simulator, and so basically commands go into Linux, telemetry back, and then interface between cFS and the simulator. So I kind of mentioned, so OpenSatKit is not designed to, support a mission lifecycle, but you can certainly do it. It's probably going to take you more work, but I recommend you tune in at 5 and see NOS 3 has already, done some hardware and device interfaces. I'm really focusing at the app level. And it's also not, configured to really address how to port the cFS framework. But as I'll give a little segue to I started a YouTube channel, and I'd love to have people contribute. So that's coming up. So this is kind of the view I have right now of the OpenSatKit and its role. The first kind of working in an arc. So it's going to be a place where you can learn the cFS, the framework. Then you can get community apps and add them. Develop some projects apps, not all projects apps, ones that depend on interfaces for instruments, for example. This is not, you still could do advanced, the algorithmic part of it, but not the interface part. And then integrate the apps into a desktop, and then there's some verification scripts that you could run. And I'll say it's kind of, and we'll find it as I go through, the maturity level, again, it was a hobby. It's still a hobby, but I'm definitely dedicating more time now. It goes from more mature, that I've got a system that's integrated and runs, and I'm adding educational material now. And then I've got more in the prototype stage, some ideas for apps and integrating them, and then in a more automated way, and then eventually get more script-based stuff going. As you'll see, a lot of it's screen-based. So it's not quite a unified product. And I have to, there's a little irony here. It's just, when we first did the CFE, and I said, I went even to some universities, said, put this thing in. They start it, we compile it, and they said, okay, what do I do? And I've had some of the same responses with OpenSatKit. You download it, you get the screen, and say, okay, now what do I start clicking? So it's got to get more user-based goals, and that's definitely a big goal that I want to do. But there is a lot of functionality there. That's what I want to emphasize. So just having an integrated working system gets you, way past the distributed nature of just assets out there. So this slide, it says, basically it's a pretty quick step. There's here's a website where there's a wiki. It has a command line for shell command for, where you can launch, install it. Sorry. Then when this is from my Ubuntu platform, you go in and you run what's called Ruby Launcher, which is Cosmos's way of starting Cosmos. Cosmos is really just a toolbox. So some people are familiar with a ground system where you're presented with a console. It's not really designed that way, and that's kind of, I've integrated a lot of pieces to make it more of an integrated tool set. So a lot of what OpenSatKit does was invoke a lot of Cosmos tools when you're trying to achieve something. So when you click this, you get the home screen. The home screen has 3 tabs. The first one, Explore cFS, and SimSat is the name I gave SimpleSat for a satellite that what the apps are pre-configured for. And it's not 100% done, but they are, a default set of apps that are, and some of them have been configured, not all of them at this point. Then here's more the app development kit tab, and then extending the OSK, and that's where, things like connecting to PySat, which is a product of Alan Cudmore that I'll get into. And then you have options to start the CFS, once just the CFS with Cosmos, obviously. And then once you can also start it with CFS with 42. So here are the default apps that are loaded. And the way to read this diagram, so this, I haven't gone into the services, but this blue line represents the software bus. And this is what we call our lollipop diagram. So the software bus is a publish subscribe messaging system. And that's pretty much, architecturally, that's a big part of the system because apps can append and poll for messages. And so it's used as data and control flow. All the blue apps are open source apps that are released by Goddard. There's other ones out there, but the ones I have in the kit are Goddard. And the green apps are OpenSatKit apps that I've written. These 3 are very much based on some open source NASA apps called Lab, like Command Ingest Lab and Telemetry Output Lab. And I had rationale for writing these, which I'll get into. And then also notice that I have functional groupings. And this is eventually where I want to target some of the educational material, because this is what I think is lacking. When you want to achieve a certain goal, it's hard to know how to assemble and use the apps as a unit. So SimpleSat, just a quick overview here. It's a fictional spacecraft, and the idea is to have a complete application suite. And I've kind of gone in, for training material, it's going to have, some, ConOps written, that we can say, oh, here are the apps that are now configured to meet these ConOps. And right now, they're pretty light. I have an integration test script, and then I have an operational script that simulates like a pass, getting data and downloading files. Yes.
Do you have support for CCSDS in the core, or is it at app level?
So if I understand the question, so the software bus messaging spec is using CCSDS packets. So that's the question. And then actually and it's packet based between Cosmos and cFS. It is not a stream. So it's actually using UDP with CCSDS packets inside. So it's not using the link protocol. And I guess while I'm on that subject, I also have, and maybe that's where I don't have CFDP, which is a CCSDS file delivery protocol. That app it's in there, but it's not fully integrated. So I still use this TFTP, Trivial File Transport Protocol app that's specific to OpenSatKit. So hopefully that answers the question.
That was great. Thank you.
Okay. So SimpleSat is there, but you can still use the kit. It's just a way to have a default configuration. And SimSat is not at this point integrated with this 42 simulator. Right now, if you start the 42 simulator, you get a closed loop simulation, but it's not related to what I mentioned with the ground pass and things like that. That would be a great goal, but at the time, it's not there yet. So first, as an educational platform, so here's the main screen, and it has a system section, and really this is so learn OpenSatKit, drop down. This is just documentation, and similar here, learn the cFS. There's a drop down, and you can get access to slides, and these are continually evolving, well, slowly. And then there's some example scripts I mentioned, and right now the functional test, needs some work. Integration test really just sends no ops to each app and tests the telemetry that the command counter incremented. So all of these are frameworks that people can start with, but they obviously need some work. And then down at the bottom, well, I'll get to those next. So at the bottom, I have one button for each of the services. And I'm going to show you the pages that pop up when you click on those. So here's an event service, and here's the table service. And I'm sorry, not the table. Actually, I got a little pop-up here. Here we go. the executive service page. And they're all outlined the same way. So the top of the page is a ground interface where you can send any command and display the telemetry using Cosmos Telemetry Packet Viewer. And this third line is actually a lot more. This is where some of the value is that, it's not quite as obvious. So a lot of the services, you can dump information to a binary file, and then you need to display that file. So when you run these, a script runs in the background that sends the command, transfers the file to the ground, then uses Table Manager's table viewer to decode the binary and display it in nice text. So then some of the screens have a functional, so like app management, executive services, you can load and unload apps and things like that. So there'll be a screen related to that. Performance monitor is a great tool that so you can put markers in your code that when you're entering an execution, and then you can and executive services will save that to a file, and then you can download that file and display in a logic analyzer type format the execution of your apps or any part of the system. And that's really handy for tuning and system engineering. Then there's some learn buttons. They're not all consistent. There's tutorials. Now I'm starting to add links to training videos, training slides. And I have another concept of demo where that's more at a functional level, but it's just hard-coded screens that you step through, and so I have a performance monitor demo, for example. So it'll actually configure the executive services, collect some data, and then launch the performance monitor. So that's run through a demo, which is a series of screens. And then at the bottom is just some housekeeping packet telemetry points from each of these services. So I guess to jump in, it's kind of sideways. So there's the YouTube training videos that I just started in June. These are short topic-specific videos, although they're putting out. It's hard to describe a service too short. But my goal was to keep them like 10 minutes, and some of the service ones are probably closer to 20. But and I'm embedding links to those. I have a handful of videos right now. I've covered free services. I've also learned to take some effort to create a video, and the Hello World app, and a code inspection of that app, and I got lots of plans. So I don't want to. Got a lot here, so I'm kind of. Hopefully, I'm not going to rush too much, but I do want to cover kind of a broad swatch here. So then at the application level, these are the exact groups that you saw in that SimSat picture. So runtime environment apps, data management apps, autonomy, maintenance, and each of those have a screen. And so here's the data management one, and it's got yellow. So for the particular group that's highlighted, all the apps involved in those you have access to through all the commands and telemetry and their specific users guides. And then I'm just now in the coming soon. So there's starting to populate some learning material that's geared to that particular goal. So here I put together, hopefully this won't be too, I'll see how this goes. So I put together some, there's no sound to it. And actually I'll pause it real quick. So it's a video of me launching a couple things, and I'll try to explain, hopefully it won't be too hectic. I can at least show you some of the things that are going on that I've described. So now I just launched Cosmos. There's the launcher. I'm going to click the button, and it's going to start a command and telemetry server, which will show up over here. So this connects, it will connect when the cFS is started it'll connect Cosmos to the cFS. And here's telemetry viewer that has all the pages defined, and it launches by default the main page. So now I'm going to start the cFS, just the cFS, and it will open up a terminal window, put in the sudo password, and now this would have been, what's being displayed here are all the event messages. And I'll stop for a second, stop the chaos. So that's where event message, if you were in a lab and you had a serial port connected, that's what you're seeing there. Now I'm going to start the system integration test script. And what this does, it started Script Runner, which is another Cosmos tool. And it also displayed 2 pages. And these pages, so on the left side, here are all the SimSat cFS applications. So these are all the open source ones. This page is the SimSat, like the mission apps. The F42 is for the flight software controller from 42. And then here are the OpenSatKit, kind of the operational apps like Blueware. And then what it's going to do is just start running the script, and we're not going to sit here and watch it. So it's basically going to send no ops to each of it does a bunch of setup, and then it does. It's actually something I use regularly when I deploy, just to make sure I didn't break something. So it's actually a handy script. Now I quickly jumped. This is the result. I issued one of those commands that dumped the binary file. It automatically launched Table Manager. And what it's doing is now going and going to open the binary file. And then you have to open a text file that describes the Cosmos, all the binary content. And in this case, this was that EVS log file. This is actually a good place to pause. So this error message, and this gets going to later when the automatic application integration that I'll talk about. So I've configured Cosmos cFS configuration parameters for the largest possible. I don't have them tuned to the actual configuration parameters that have been deployed with the cFS. So it's giving me an error or warning, really, that says the file dumped isn't as big as your binary file definition. So that's why that's going on. And that's one of the things I'd like to fix with, the concept of packaging an app and having a description. So there's the contents of a binary. This is the event service application info file. Here's a demo, and I think in light of time, this was the performance monitor demo. I'm just going to move it ahead and get to, so it launched at the end, the performance monitor tool, which is this box. And this was actually open sourced by Johnson Space Center. And this is what a performance app, it's showing the logic analyzer. So there's this particular app, I know it's not symbolic here, it's using performance IDs, but this was using memory dwell that runs at 1 hertz, and it was capturing some file manager activity of when it did particular task. So it's a very handy tool. I just at least want to give it some exposure here. And then the last thing I was going to show here was just, so I pointed out there's some tutorials. So here, when you click on table services, you'll get the table services slides. Then if you want to go to the video, it'll go to the website and get the YouTube training video.
Dave?
Yes.
Does Cosmos get installed with the OSK?
Yes. So they'll install that, the script that is on the wiki, or a pointer to it. It'll install Cosmos 42 and cFS.
Thank you.
Hmm? So from the kit point of view, like I said, this is starting that now we're going from more mature to a little more thought things here, and I'm always interested in people's ideas as well. So I've done some prototyping, but so the idea is to have an application packaging spec and a tool chain that would let you can discover apps, retrieve them, and integrate them. Really, I'm talking pretty much an app store, but it's going to take a little work to get to this from a community. And if you did tune in Alan's talk yesterday or Matt's later, you're going to see that from Goddard, from a small sat perspective, they're already doing kind of what I have in mind from a broader community sense. They have a product line of apps that they've tuned and maintained for their CubeSats. And it's a little easier to do it in their environment rather than a generalized solution. Because they control the environment. So this is going to, it's going to take some work to get there. Some technical challenges. I'm sorry?
We have another question.
Okay.
Is there a difference between NASA CFS repos ground system.py and the OSK repos control panel?
Yes. So that's a Python ground system that gives you some basic command and telemetry interface. And you can extend that as well. Yes, but it's a two different tool sets. That's interesting. I haven't actually launched or integrated into any aspect of this at this time. And so, okay, thinking back to the application integration. So there's challenges when you integrate apps. You got message IDs from the different apps. You got project configuration parameters, as we saw in the demo. It's they got downstream artifacts. So you really want one definition and then have a tool chain that manages the system. And then similar to that problem is the binary message definitions. You want one definition and you want an internal across the process, in the processor and also on the wire. So my thought here, and this is kind of, this is fairly recent because the YouTube channel is only 2 months old, but I started thinking a little broader as I started throwing educational, started thinking, well, why couldn't it be even more where other people contribute videos and it could be more of a product and service, more like a marketplace in general. And maybe we could start getting more assets out there in a more centralized way where people could find them. So this is a conceptual idea, more technical, and I don't want to get too bogged down in it because this is an overview, but the idea is that these cubes represent an app as opposed to a circle. And they would have an app spec of some sort, some kind of manifest or metadata. They got the source code, the unit test, and ideally that we could even get the functional test scripts, which we don't have. I mean, the open source ones have assist test scripts, but unless you have an assist ground system, that's not going to do you a lot of good. Then the projects, you're going to create new apps. They're going to have specific configurations, and they're also going to develop new functional scripts. So ideally, you want some kind of tool chain that could take the source directory and know all the information there. It could create header files for the apps, and then it could also create bindings. And whoops, we'll get to that. There's an example. There's actually a prototype of this existing. And then these bindings, right now the prototype has Lua, and there's also, and I think Python as well. And similarly, the tool chain could make the command and telemetry definitions available to the test executive and any configuration parameters that are needed. So that's the general idea of the flow. And by test executive, I kept that generic right now. The prototype that I'm aware of actually runs Lua scripts. And, it could be, maybe this is going to be Ruby scripts, Cosmos, or it could be Python or Lua, but the idea is some sort of executive that lets people package apps with functional tests that in a consistent way. So I'm not going to go, this is pretty much in words except this middle part here. So Canada Solutions, NASA Glenn, I think it was about 2 months ago, released their CCSDS electronic data sheet tool chain. And this is, the EDS is by the CCSDS committee, it's an XML data model. And right now, the current core flight executive has EDS specs with it, but it's not delivered with a tool chain either. So I was going to start looking into this as, integrating it into the tool. But I'm also aware of Emergent Space Technology has a program called Yeti, and that uses a JSON data model that pretty much does the same functional flow. And those are the two I'm aware of. And that's about all I was going to cover there. So then getting back to, now we did start the app development screen. So now we're to the screen itself. So as you can see, these dark gray they're not implemented yet. So we're getting, as I said, more conceptually. I do have, there's some links to some training and guides, but some of those might even repeat from other ones. The two functional buttons are create app, and that actually is just a series of steps that lets you create an app, a Hello World app. And I've been playing around with this add app feature that lets you add an app that hasn't been loaded, but it has been built within OpenSatKit. So it's not out on the web somewhere, but it's the beginning of getting me thinking through the process of how that might look. So before I jump, and then down at the bottom, some performance management tools that we'd already seen. But I do got to back up. So the idea of having these integratable apps and, discoverable, integratable, and, automated process, I think we're going to need to change some of the app packaging, maybe even the app framework itself. So the current apps are based, there's an application developer's guide that describes, a structure of an app and how to use the CFE APIs. And it's a good document. I'm not, knocking it. It's been used for all our open source apps. It is written in a more procedural style, which, maybe I've been playing around with more of an object-oriented way, and it seems to be lending itself more to more of the dynamic and integration that I'm looking for. So one of the reasons I wrote the OpenSatKit apps the way I did is I wanted text-based tables rather than binary. And I've used JSON, and I wanted that so I could automatically have tools go in and change the scheduler table or go in and change the telemetry output table. And it could, easily edit the text-based tables to integrate into this kit. You may not want to do that on flight, but from a kit point of view, it makes the tooling much easier. So now if I'm going to have a JSON table in apps, I wanted it just to be one for all of the apps. So I created a framework that has a lot of the common functionality for a lot of apps. It's not a huge framework, but it's got some common things, and they all link to the same framework. And in this framework is a JSON parser for the JSON tables. So it just lent itself to, and then the apps really have a similar structure. Some other things I've been doing, and I hesitate to mention this one because I haven't really fleshed it out, but I did throw it out publicly. There's a prototype C++ application framework that has pretty much the same design as the object-based one, but it's true inheritance and things like that. And that one, I've written a demo app, but I haven't unit tested either of these frameworks, by the way. So, but the top one, the C one, has been used a lot, so I'm pretty confident in that. But so as a kind of another exercise, I'm refactoring the current file manager app using the C framework, and I'm kind of looking at it to see what happens and see whether it gets any easier to package this app and see how the structure changes. And as I'm doing that, I'm also looking at having ini files for apps, because what I noticed is I really dug deep in the file manager, and I don't know if this is across the board, but what needs to be a compile time parameter versus a runtime configuration parameter. And I'm seeing that it's a very small number of compile time parameters, really. And a lot of them could just be in an ini file. And that really simplifies the configuration and dependency down the artifact tool chain. If we can have, and it also makes it easier to move apps around that in terms of if you want to just move it to this processor and have multiple instances of it, things that could be just in an ini file. And again, the framework would take care of processing that ini file in a constant, consistent way. One other tool I want to mention is external code interface real quick. This is, I don't have it in here yet, but Ames developed a Simulink interface layer, which lets you generate code from Simulink and plug it in as an app. Goddard, and led by Steve Lentini, really separated that into an external code interface, which is really just generic, and then the Simulink interface layer really just generates code to that external code interface. So really any tool could generate code that could plug in as a cFS app. And that'd be a nice feature to have, because actually if something like the 42 simulator, which is written in C, complied with that interface, we could just move the controller code over. So there's ways to be thinking about getting algorithm-based apps into the kit. So here's the create at screen. I'm just going to mention, since I mentioned there's a different, it has templates, it's template driven. And so it can create a hello world for the application developers guide or for the C framework. And there's also a sample app one that's in there. And I'm not sure if that still exists or not. My goal is that they're in work of creating some more templates that support the binary files and the C++ framework. But it really is just 6 steps. You only have to do 2 small edits, and when you're done, you have an app that runs, has the command and telemetry pages with a no-op command, and basically, hello. Then the add app, I mentioned that. So this drop-down menu is it's dynamically generated based on looking at what's running on board, what was built locally, and then giving you the option of whether you want to load it or not. And then you can get a description that comes from the app spec that I've been playing around with. So this is just some prototype work that's looking at adding an app from a catalog. So it's very preliminary, but getting me there. So I thought I'd show you at the end of the last section, I had a quick video, and it was a little hectic with the clicking. So I thought I would show you, since I haven't covered it yet. Here is 42 running with cFS. So this screen here is 42's graphics. There's its graphics. And what I have in the middle here is the controller table for the F42 app. And it lets you load parameters. And I'm plotting the attitude error here. And what I just did was load a bad controller value. And you can see the attitude errors start really going bonkers. And this is also a 42 simulation page that was kind of consolidates a lot of the information for the 42. This was actually done in part for a class of a spacecraft systems class. So it was trying to abstract it out so the students could play with the controller and also plot different values. So that was really the purpose of putting this together. But I got to say, this is all JSON driven, and it was very nice because it's a JSON table. So I could just, it's pretty quick to just parse JSON, populate in a table, and send it up. So having a JSON table there was very convenient. And then as you can see, then it says restore defaults, and you can see the control errors now start to behave. So that was and I think I'm getting close to the end. So kit extensions, we even get further into the unknown. So we got placeholder page, but it does have a couple things here. One, in the remote targets, Alan Cudmore developed, and very grateful for him for he something he called a PySat, and I'll have a quick video in a second. And this is using a Raspberry Pi Zero, and he installed the cFS on there and has some apps that read some hardware, things like an accelerometer, magnetometer, and then it goes wireless to OpenSatKit. And that's been a very nice presentation tool in classrooms. And right now, all the code's there, but it doesn't do you a lot of good because you got to manually configure Cosmos and then restart it. And so it is an effort. And there's also a prototype benchmark app that I had an intern develop for me. And obviously that would need to be installed on a target. And that, but it's a start. And that's kind of where this is going. I could also see adding self-robust network, and I've seen people bridge the robotic operating system. So this one's kind of the next steps. So here's the video. So this is Alan's PySat, and so it's got the Raspberry Pi. He's actually got a display panel, and he's got his power deck, and then at the bottom he had that's where the sensors are. So here's my advanced spin table. So it's spun it, and now we're going to go to the screen, and you're going to see. So I'm plotting the accelerometer data here. So it was flat before I spun it, and now you can see it's changing in all three axes. These other screens, this is kind of a summary screen of the different data. And this screen on the left was that same screen you saw with all the cFS apps. So they were all installed, or most of them. There's one not updating, but that's the PySat. And that kind of wraps it up. So where I'm going next, it's kind of organized the same three ways. There's lots on my to-do list. As an educational platform, I want to continue adding videos. And again, I would love to open up to the community with people, especially in the porting area. That's an area we see a lot on the cFS mailing list. So if somebody wanted to create a video there and how to port to the platform, this could be a venue where we just put videos up. I'm going to continue looking at the packaging and refactoring and looking at application integration models, and eventually get to the unit test and functional test support. And right now, actually, in the Kit extensions, I think Software Bus, I don't know what version it I can't remember if it compiles by default or not, but I have a version I started to play with. And the bundle protocol is part of the delay tolerant network. And I think that's being open sourced. If it's not, it's going to be open source soon. So that's part of the challenge here too, is, I can only do things that are open source. And from a system point of view, I want to start getting more script-based things and even document the scripts. Because now I've got my own little scripting API starting to build up that I use, and that's not documented at all. So I want to get it more task-oriented or user-oriented, where people can do things.
Dave?
So, yes.
You have a few questions.
Okay.
The first one is there a repo or Git where we can follow or recreate the PySat to get started with the framework?
Wow. The best thing to do would be to email me. No, there isn't. Alan did have a parts list, but he's moved way beyond the PySat he lets me use. So he has a million ideas. I don't know if he's online, but it would be, yes, if you get in touch with me, I can get you in touch with Alan and we can work together, because he's done a lot of, and he's done a lot of things in terms of keeping the cost down too. I can't remember what the cost of this particular one was. It wasn't expensive relative to things. But we can certainly get to the parts list, but I'm not sure if all the source, I don't think that source was open sourced either. So we definitely need a conversation.
I'll put an email address in the chat.
Okay, thank you.
And the next question is, you mentioned table uplinks. What about flight software patch uplinks as when we're maintaining the FSW in orbit?
Yeah, that's a good question. I have not tried. Well, actually, that's not true. So there's a demo. I have a demo for that. There's a demo in the memory management section. And I have actually gone through the steps of using Memory Manager to show you how to patch a location. It's kind of, that's why I say there's a lot of stuff there, but it's kind of buried. But again, if somebody wants to email me, but there is a demo that goes through the steps. And you got to be careful, because here I am running on Linux. I mean, anytime you patch and upgrade, that's a challenge if you're doing it at the memory location. So the other model here is, and we actually use this on GPM, is that you replace whole apps. And that's a much more powerful model. Of course, it's got its challenges, because you have an app, and depending on where it is in the food chain of data, if you pull an app out and all the software bus messages fall on the floor, it depends on what that app is. But on GPM, we replaced the CFDP app in orbit. And that was done. And the nice thing there is you don't have to go down to a safe mode. That's typically maybe I'm showing my age, but you go down to a safe hold mode, change some code, and then have to boot back into an operational mode. So yes, the answer is yes. The short answer is yes. There's a memory management demo.
And you have another question, and there's about 2 minutes left. So
okay, if I can interrupt, sorry, I'm going to go to the resource slides, so they'll be up at least in the video. So here's the first one. Okay.
Perfect. So the question is, are there any tutorials or examples that demonstrate how to use cFS with 2 single board computers or multi-core systems?
No, no, there's not. And that's kind of on that extension with the software bus network. It's, and unfortunately, it's probably going to be a little while. I don't have any example. I don't know if anybody, I can ask around. Again, I'd be happy if anybody wants to contact me. But it's probably going to be a little while for OpenSatKit to get there. But people have used it, and Pace is a current in-house Goddard mission that's using 2 cores. So.
And I did put your email address in the chat. So if anyone wants to reach out to Dave for more information on what he's talked about today, or if you're interested in partnering with him, I did see a comment about that. Please use that email address.
Okay, I mean, that was the end. I appreciate everybody's time. I didn't even get to the thank you chart, but there was a thank you chart back there, and I do appreciate everybody tuning in, and hope this was helpful.
Thank you so much, Dave, and thank you to everyone who joined in with us. We appreciate all of your time, and if you do have questions, please continue the conversation by reaching out to Dave. And don't forget to join us for our next presentation with Matthew Grubb. You can access the WebEx link from our events page on our website. I did put the link in chat, and I will add it again. Thank you. Have a great evening.
Thanks, Aaron.
Thanks, Dave.